You realize that many plants have spirals and have started counting how many spirals plants have to see if there's any sort of pattern. Pine cones are fun because you can use markers to draw on them. This pine cone has 8 of these loose spirals and then 5 tight spirals going the opposite direction. This pine cone is the same. This pine cone is a little wonky looking, but it also follows the 5 and 8 pattern. Here is a different type of pine cone. Maybe it will have a different spiral pattern? Let's see. It is 8 and 13. You decide to count the spirals on a different plant altogether. How about this daisy? This one has 13 spirals, and the daisy I looked at in part 2 of this series has 34. The number 13 appears again in the petals on this black-eyed Susan. So do these numbers, 5, 8, 13, and 34, have anything in common with each other? In fact, they do. All these numbers are part of the Fibonacci sequence. The Fibonacci sequence is a series of numbers that is found by adding the previous number in the sequence. You start at 0 and add 1. Now 0 plus 1 equals 1, and 1 plus 1 equals 2. Now 1 plus 2 equals 3, and 2 plus 3 equals 5. 3 plus 5 is 8. 5 plus 8 equals 13. Add 8 to 13 and you get 21. Next comes 34. We can keep going like this to get 55, 89, 144, 233, 377, 610, 987, 1597, 2584, 4181, 6765, 10946, 17711, 28657, 46368, and so on. This sequence is named after Italian Leonardo Fibonacci, who in 1202 AD wrote a book in which he described the sequence. However, it has also appeared in Indian mathematics before this date. Fibonacci introduced the sequence as a method of figuring out the growth of a population of rabbits. Since then, the sequence and related mathematical patterns have been documented in many aspects of the natural world. If you want to get really mathematical, you can look at the recursive formula for the Fibonacci sequence. The formula is Fn equals Fn minus 1 plus Fn minus 2, where F0 equals 0 and F1 equals 1. The n represents the number in the sequence. So F0 is the 0th number in the sequence, and F1 is the first number of the sequence. Next, we can find the second term in the sequence. First, we make n equal 2. So F2 equals F2 minus 1 plus F2 minus 2. Now we subtract the subscript numbers, so 2 minus 1 equals 1, and 2 minus 2 equals 0. Now we know F1 equals 1, so we can input that, and we know F0 equals 0. 1 plus 0 equals 1, which means that the second term in the sequence is 1. We can keep going like this to find all the remaining terms. Of course, all we are doing here is adding the previous number in the sequence, but this is how the mathematical recursive formula is written out. Now, pine cones and daisies are not the only plants with spirals in a Fibonacci pattern. It is slightly difficult to count because of all the petals, but this marigold has a set of 8 spirals. Sunflowers can reach really high numbers. Some even have up to 144. Mine has 21 counterclockwise spirals. You can also find lots of lower Fibonacci numbers. This clover and poison ivy are in sets of 3. The petals of this flower are in sets of 5, and this lily seems to have 2 sets of 3. You might start thinking that Fibonacci numbers are everywhere in nature, but although you see Fibonacci numbers very often, there are anomalies and some plants follow different patterns. I was counting the number of spirals on this daisy, and there are 34 clockwise spirals, which is a Fibonacci number. However, there are 22 counterclockwise spirals, which is 1 digit over the Fibonacci number 21. This flower has only 4 petals, and daffodils have 6. Maybe these plants follow a different pattern or are just unique? Something to look at next time.
Pinnguaq.